These are a couple examples of stacked triangles and using special right triangles to solve them. So when you start these problems, you're going to want to focus on the triangle typically that doesn't have x with it. So whatever has a number labeled, so this triangle here that I'm highlighting in red has 10 labeled. So that would be helpful to us. So we're going to start with that triangle. So I took this triangle and I just redrew it out here so that you could see it a little better and I could write next to it. And so remember, when you start these problems, you label using your formula. So the formula for 45, 45, 90 is x square root of 2. And x square root of 2 is always on the hypotenuse. Whenever we have two items on the same side, we're going to set them equal to each other. And then we're going to solve for x. So we're going to divide both sides by square root of 2. These square root of 2's are going to cancel out. And right now I have x equals 10 over square root of 2. Now you can't leave a radical on the bottom, so we're going to do times square root of 2 over square root of 2. When I multiply across the top, 10 times square root of 2, they can't be combined because they're not both in a radical, so I just get 10 square root of 2. On the bottom, I get square root of 2 times square root of 2 square root of 4, and square root of 4 is really just 2. And then lastly, I can simplify this fraction, 10 over 2, and 10 over 2 is really the same as 5, so I end up with x equals 5 square root of 2. So this side's going to be 5 square root of 2, and this side would be 5 square root of 2. So if I go back to my original problem, I can label those two sides. And now I can focus on my second triangle, which I highlighted in blue. I redrew the blue triangle out here so that you can see it a little better and we can label it. So same thing, I'm going to start with my formula, so x, and then x squared root of 2. On the side that I have two things on, I'm going to go ahead and set those equal to each other. To solve this, I would have to divide both sides by square root of 2. And that's going to make these square root of 2's cancel out, and then I can see that x is 5. And so this top side here was originally what I was looking for. And so x is 5. On this second example, I still have two 45, 45, 90 triangles. And again, I want to start with the triangle that has a number labeled and not the x. So whichever one has something labeled. So I'm going to start with this red triangle here. I went ahead and redrew that triangle so that we could label it. And so if I label, I'm going to label x square root of 2 on my hypotenuse. The side that has two labels on it, I'm going to set them equal to each other. And then I'm going to solve by dividing by square root of 2 on both sides, which makes those square root of 2's cancel out. So I end up with x equals 5, which makes this side 5 and also this side 5. So if I go back to my original triangle and fill those in, it would look like this. Once I have that filled in, I can go to my second triangle, which is going to be this one right here that I'm highlighting in blue, and I can start to solve that one. I went ahead and redrew that next triangle so that we can label it, and again, so I label x, the hypotenuse is x square root of 2. Since I have two labels on the same side, I set those equal, and then I'm going to start solving. When I solve this one, I'm going to have to divide both sides by square root of 2. And so I'm going to get 5 over square root of 2 equals x. We can't leave the square root on the bottom, so to solve that, I'm going to have to rationalize the denominator, which we do by multiplying by square root of 2 over square root of 2. I multiply across the top. 5 times square root of 2 is 5 square root of 2. Square root of 2 times square root of 2 is square root of 4, which is 2. Double checking my fraction, I have 5 halves, which doesn't simplify, so I'm just going to leave that as is. And so this is going to be what x equals. So if I went back here and labeled, this side is 5 square root of 2 over 2, and so is this side. If you look at our original problem, it wanted me to figure out what this side here was, so I got 5 square root of 2 over 2. On this last example, I have a 30, 60, 90 triangle, and I also have a 45, 45, 90. So we're going to have to use two different formulas. Again, we want to start with the triangle that has a number labeled for a side, so the one I just highlighted in red, which is the 30, 60, 90. Since it's a 30, 60, 90 triangle, the formula is different than what we've been using. So across from the 30 is always x, the hypotenuse is always 2x, and the third side is always x square root of 3. Since I have two labels on this top side, I'm going to solve for x here. I'm going to solve for x by dividing both sides by square root of 3. But I cannot leave the square root of 3 on the bottom, so then I do times square root of 3 over square root of 3. If I multiply across the top, I get 6 square root of 3. If I multiply across the bottom, I get square root of 9, which is really just 3. And then lastly, if I check out my fraction, I have 6 divided by 3, and 6 divided by 3 is really 2. So for x, I'm getting 2 square root of 3. I can then plug that back in up top. So on the right side, I have that side that is 2 square root of 3. And here, I have 2 times 2 square root of 3, which is just 4 square root of 3. If I go back to my original triangle and label those, it would look like this. And then I can move to my bottom triangle to start solving for that missing side. So now I'm going to focus on the blue triangle, which I redrew out here. And if we go to label this triangle using our formula, it's x, x, and the hypotenuse is x square root of 2. On the side that has two labels, I set them equal, and so 4 square root of 3 equals x. So if I plug that in on this side here, I have 4 square root of 3 times square root of 2. I can multiply the square root of 3 and square root of 2 together since they're both in a radical, and I get 4 square root of 6. I can't simplify square root of 6 because it doesn't have any factors that are perfect squares, so this would just be my final answer for this side. And if I come back over to my original triangle and label, the side they asked me to solve for was 4 square root of 6.